Let's take a look at this problem. Got 5x minus y is equal to 11. 3x plus 4y is equal to 7. And it says solve each system by the substitution method. We'll first do substitution and then we'll use calculator. Step 1. Solve one of the equations for one of the variables. Probably our easiest one is the first one. We've got 5x minus y is equal to 11. And I'm going to solve it for y. So I'm going to take the negative y to the right side, and I'll take the 11 to the left side. You take anything across your equals, your sign changes. So the 11 becomes a negative 11, and the negative y becomes a positive y. Step 2, plug this into your other equation and solve. Other equation is 3x plus 4y is equal to 7. So we got 3x plus 4. Okay. Now here we said y is equal to 5x minus 11. So we're going to replace the y right here with 5x minus 11. So this is 3x plus 4 times 5x minus 11 equals 7. And then we want to solve. Well, 4 times 5 gives us 20x. 4 times negative 44, or 4 times negative 11 gives us negative 44 equals 7. Combine together like terms. 2x plus 20x is 23x. And I'll take the negative 44 to the right side and it becomes a positive 44. So we got 23x is equal to 51. Divide both sides by 23 and we get x is equal to 51 over 23. Now I'm going to check that. That seems kind of funny. Okay, 5x minus y is equal to 11. Okay, y is equal to that. 3x plus 4y is equal to 7. Replace that with 5x minus 11. So we got 3x, 4, that's 20x, negative 44 equals 7. 23x, take that over. Okay, that gives 51. Well, it looks right. Okay. Step 3. Plug this into the equation from step 1 and solve. Our equation from step 1 is already solved for y, so that's a perfect one. We got y is equal to 5x minus 11. We just said x is equal to 51 over 23, so there's going to be 5 times 51 over 23. Plug this in for the x. Minus 11. Okay, that's going to give us 255 over 23 minus 11. And I'm going to use my calculator. I'm going to be lazy here. 255 divided by 23 minus 11, enter, and then math, enter. 2 over 23. So our answer, assuming I didn't make a screw up somewhere, 51 over 23 and 2 over 23. Well, let's do this on the calculator and see if I did mess up. It's already in a perfect form. We got all the variable terms on the left side, constant terms on the right side. X's are lined up, Y's are lined up, and numbers lined up on the other side of the equals. So we're going to drop our variables, drop our equals, keep the numbers in our signs, and create a matrix. So we got 5, negative 1, 11, 3, 4, and 7. This is a 2 by 3. So let's go enter this in. I'll do second, x and negative 1, go to my matrix, that's the inverse. And go over to edit, do enter on A. It's 2 by 3, so do 2 enter, 3 enter. And I got 5 enter, negative 1 enter. 11 enter, 3 enter. 4 enter, 7 enter. Exit out, do second mode, and then I'll do second x negative 1, go over to RAF, up arrow to RAF, or right arrow over to math, and up arrow to RAF. Been creating too many of these videos today, I think. Then do second x negative 1, enter on A, enter again. get decimals, which should be because we got fractions on the other one, but let's do a math enter to change them. So math enter. And that looks promising. So we came up with 51 over 23 and 2 over 23. Two equations, two variables. This first 2 by 2 here should be a diagonal of 1, 0, 0 else. If it is, that means it worked. And if it worked, your far right column is your answer. This will be your x, and this will be your y. It's in the same order you put your numbers. We put our x's here, we put our y's here. And we put parentheses around it and comma between them. So we've got 51 over 23, comma, 2 over 23. And you see we get the same answer as what we did by hand.